Hi everyone. So I'm Saral Nashier again with you with the next set from CAT 2018 afternoon slot. It is a set theory set from LRDI section. We have already discussed the set from the morning slot, and now we are going to discuss the other set which came in the afternoon slot. So let us straight away start with the set now. So here it says Fun Sports provides training in 3 sports: Gilli Danda, Kho-Kho and Ludo. Currently it has enrollment of 39 students, each of whom is enrolled in at least one of the 3 sports. The following details are given to us. So basically he is talking about 3 sets again: Gilli Danda, Kho-Kho and Ludo. And in the information we see that again there is a specific information. We have already discussed about it in the last set as well, that whenever there is a specific information, you always make Venn diagrams. Otherwise, when the information is not that specific, it is talking about 2 sets or 3 sets straight away, in those cases we talk about those token approaches. Also, because there are only 3 sets, so we have to make a Venn diagram of 3 only here. Now the next important part is, it says that the number of students enrolled only in L is double the number of students enrolled in all the 3 sports. There is the next information, total of 17 students are there. So it is not necessary that we use the first information first, the second one, then the third one, and so on and so forth. So we'll have to look at these informations according to our use. I mean, look for those informations first which will give you the exact information. For example, here if I talk about the second statement which says there are a total of 17 students enrolled in GE, I should start with this statement because it gives us the exact information. Now no other statement is giving us the exact information, but in that case I'll choose the best one, which is statement 1, that talks about the number of students enrolled only in L is double the number of students enrolled in all the 3 sports, right? Because this will now introduce one variable. After that, I see that it talks about only in L, and then again third statement as well talks about only in L. So the next statement that I should be using is statement 3. So that way I choose my order accordingly such that my solution becomes easy, right? So I'll move to the next solution page now, and we'll talk about the solution. I put up that information in a concise manner in this box. We'll be using these informations now. Let's start making the Venn diagram. So it's a Venn diagram of 3 sets. G stands for Gilli Danda, K is for Kho-Kho and L is for Ludo. So let us start with second statement, which says there are a total of 17 students enrolled in GE. So this can straight away be put here such that the first circle represents 17. Now I'll talk about statement 1, which says the number of students enrolled only in L is double the number of students enrolled in all the 3 sports. So I am assuming the area with all the 3 sports as A, so obviously only L would become 2A. This is quite easy to put in. So I'll move to the next statement now. The third statement says the number of students enrolled only in G is 1 less than the number of students only in L. We already have the area of only in L. So the area with only in G would automatically be 2A minus 1. So till now there is no problem in putting up these informations because these are straightforward information, so we can straight away put them here. So I'll move to statement number 4 now, which obviously is 6th in the given data set to us. It says 10 students enrolled in G are also enrolled in at least one more sport. So now the point is that which area represents this? G and at least one more sport. So G and at least one more, that means the area which is already in circle G. So there are 4 areas in circle G, right? One area is this, which is 2A minus 1. One area is this, that is A, and the other 2 areas are these 2 areas. So the person should also be enrolled in at least one more sport. So obviously I'll not be looking at 2A minus 1 area. That area would be rejected. So the remaining 3 areas add up to 10. That means automatically the value of 2A minus 1 would become 17 minus 10, which is 7. And it gives us the value of A. So when it gives us the value of A, that means all those values which are in terms of A, we can put those values now. So A would become 4, 2A would become 8, and similarly 2A minus 1 would become 7. Okay, So we have used this information now. So we'll move to the next one now, which is statement number 4 in the data set. It says the number of students enrolled only in K is equal to the number of students who are enrolled in both K and L. So which area represents both K and L? So let us say this area is X. So the number of students enrolled only in K should be equal to both K and L. That means the number representing area only K should also be X. This is a very common mistake students also make, that when we look at both K and L, what comes to our mind first is both K and L but not G, though it is not saying that. So that area should not be equal to X. Actually that area should be equal to 4 plus X. Because when you say both K and L, both K and L would be an area which is in both K and L, and it does not talk about G. So that means this complete area would actually be representing both K and L, right? So therefore we are using this as 4 plus X. Okay, so I'll move forward now. Now in circle G, we see that the total circle is equal to 17. We already have two areas as 7 and 4. That means the remaining two areas must add up to 6, right? So I'm assuming one of those two areas as Y, and the other area would automatically become 6 minus Y. Now, the original information which is given to us is currently it has an enrollment of 39 students. That means all these areas which I see here in these three circles should add up to 39. Here again, normally what we do, we put sum of all the areas and we put that sum equal to 39. Though that will unnecessarily waste some of your time, because if you closely look at this circle G, it itself is equal to 17, right? That means the remaining three areas now, which is 4 plus X, X and 8, they should add up to 39 minus 17, which gives us the value of X straight away as 5. Now putting up these values of X in the Venn diagram, we get these values as 9 and 5. So in the whole Venn diagram, I see the only variable left is Y now. So we have only one variable left, and we have one information left which is unused till now, that is information number 5. It says the maximum student enrollment is in L. So we'll have to figure out the total enrollment of L, G and K. Look at the total enrollments of these now. Because L should be greater than G as well as that is greater than K. So the total circle L would be this complete circle which contains these four values L, Y, 4, 5 and 8. If you add these four values, they become 17 plus Y, and this 17 plus Y should be greater than obviously G, which is equal to 17, and K, that is the sum of the areas which are in circle K. So I am putting 17 plus Y as greater than 17 now, and 17 plus Y also greater than K, which is 24 minus Y. Solving these two, you get Y is greater than 3.5, and also we get 6 minus Y is greater than equal to 0. Where from this value comes? That this variable obviously cannot be negative. So it has to be greater than or equal to 0. So from this whole thing we get to know that Y is greater than equal to 3.5, and the second information says Y is less than or equal to 6. Hence we get to know that Y can only be 4, 5 or 6. Greater than 3.5, less than or equal to 6. So these are the three values which are possible. Now whatever questions will be having on this set, they automatically would be based upon this value of Y only. So let's move on to the questions. So the first question with us is, what is the minimum number of students enrolled in both G and L but not K? Let's look at the Venn diagram. So which area is represented by both G and L but not K? That area is represented by Y here. So basically the question is asking us the minimum number of students which represents the value of Y, and because we already know that Y has the minimum value of 4, so the answer to this question should be straight away 4. So let's move to the next question. If the number of students enrolled in K and L are in the ratio of 19:22, then what is the number of students enrolled in L? Again, let's have a look at the Venn diagram. The number of students enrolled in K and the number of students enrolled in L. So how many students are enrolled in K? We have to add up all those values. This gives us 24 minus Y. And students enrolled in L, that gives us 17 plus Y. The question says they should be in a ratio of 19:22, and we already know y can only be 4, 5 or 6. So just by pitching in these values, you can understand that y is equal to 5 will satisfy this condition, and therefore the number of students enrolled in L should be 22. Though I would say that for this question I did not need any kind of information whatsoever, no Venn diagram, no value y, because straight away the question itself says the number of students enrolled in K and L are in the ratio of 19:22. So automatically the number of students enrolled in L must be a multiple of 22, and among the options the only number which is a multiple of 22 is option 4. So I can straight away could have answered this question even without looking at anything else in the complete set. Though I mean while solving this set we do not know whether such a question would appear there or not. So I'm not saying that every student should get to know about such a thing, but sometimes it is possible you are going through this set and you pass through such an information. So sometimes you can get some questions without even solving anything from the set. Let's move to the next question now. Now this question, though it's slightly lengthy, so during the exam probably I should not be doing this question, but I see that this question and the next question, they both are based upon the same data. So if one information is giving us two questions, so I think we should go forward with this. So the question says, due to the academic pressure, students who were enrolled in all three sports were asked to withdraw from one of the three sports. That means people who are there in the area which is common in all three, they are to be taken out from that area, they are to be withdrawn. The number of students enrolled in G was 6 less than the number of students enrolled in L after doing this, after the withdrawal, and the number of students enrolled in K went down by 1. So the first important information is that the number of students enrolled in K went down by 1, which automatically means one student opted out of K. If one student will opt out of K, that means the area which is common among all three would become 3, and the area which is in G and L but not K would become y plus 1. G and L but not K would become y plus 1, because one kid will come out of the area which is common in all three, and he is withdrawing from K only. That means he will move into the area which is common in G and L. Now we do not know how many people withdrew from G or L, so I am assuming these numbers, because in total we know that 3 more people opted out. So I am assuming that A people opted out of G and 3 minus A opted out of L. So when A people will move out of G, that means they will automatically come into the area of L and K, which is represented by 5 here. So that area 5 would be replaced by 5 plus A, right? Similarly, the other 3 minus A people, they'll go into the area which is G and K but not L, that is represented by 6 minus Y here. So that area 6 minus Y would be replaced by 6 minus Y plus 3 minus A. And the area which is common in all three will automatically turn into 0 now, because every person has opted out. So these are the figures with us now. Now the next information which was given to us in the question was the number of students enrolled in G was 6 less than the number of students enrolled in L. So how many students are enrolled in G now? I'll add up all the areas of circle G. Similarly, how many students are there in L now? I'll add up all the areas of circle L. So circle G adds up to 17 minus A, and circle L adds up to 14 plus Y plus A, because the difference of these two is 6. So by making this equation we get to know that Y plus 2A is equal to 9. Now we do not know what are the values of A, but we already know that Y can only be either 4 or 5 or 6. So either you put in all these values and check what all values of A can be there, or if you look at this equation closely, you'll see that 9 is an odd number, 2A has to be an even number, whatever A is. So an even number should be added into something such that you get an odd number. So that something which is Y here should also be odd, and hence it can only be 5. So that means the only possible value of Y here can be 5. And when you put that value of 5 here, you get the value of A as 2. Now the question is asking us that after the withdrawal, how many students were enrolled in both G and K. In G and K, we see the number of people is 6 minus Y plus 3 minus A. We already have Y with us as 5. We already have A with us as 2. By putting these values, I get the value of this number as 2. So this was a slightly lengthier question, but as I told you, there is another question based upon this. So it was worth doing. So now I'll move on to the last question. So whole data is same except the last line, the last question, which says after the withdrawal, how many students were enrolled in both G and L. So I'll come to the same Venn diagram which we formed in the last question. And in that last question, we got to know that Y is equal to 5 and A is equal to 2. Now the question is asking you, how many students were enrolled in both G and L? So when I see both G and L, that area would be Y plus 1, right? No, it is Y plus 1 plus 0 as well, right? So keep your basics in mind, though that value is 0 and adding that would not make a difference, but it should always be in our mind that whenever I say both G and L, I should consider Y plus 1 as well as 0. So by adding Y plus 1 with 0, we get the value as 9 because we already have the value of Y as 5. So total value becomes 9 and hence the answer to this question would be equal to 9. So just like the previous set, we see in this set as well, we are able to minimize our number of variables, and that has made the question look very easy. Though I would again tell you that these questions are considered to be on the tougher side in those LRDI sections. So there were easier sets as well. But still, if you look at them closely and do it with a proper method and do it with a proper strategy by minimizing the number of variables, you can actually make them look very easy. Okay, so this was all about today, and we'll be discussing about the other two sets from LRDI 17 as well, which are again based upon set theory in the coming days. So stay connected. Thank you.